myself, I am Umamaheshwar Reddy here. So, I teach mathematics. So, my qualification is MSc, M.Phil, B.Ed. So, I have been teaching for the last 25-30 years. So, actually, earlier I taught for BSc students. So, now for the last 6-7 years, I have been teaching for IIT JEE classes and IIT Foundation classes. So, especially the most of the students come from CBSE background, where I am teaching for CBSE students. So, let me start a small topic in intermediate second year. The topic is integration. So, what is integration means? It is only antiderivative it is. So, the derivative of log x is 1 by x. So, the integration of 1 by x is log x. It's just the reverse of differentiation, you can say the antiderivative. So, what is integration means? It is antiderivative. Derivative of d by dx of sin x. D by dx of sin x is cos x. Integration of cos x is sin x. So, here just antiderivative, reverse of differentiation. So, there are some formulas here. Integration of x power n dx is x power n plus 1 by n plus 1. This formula is true only when n is not equal to minus 1, right. So, when n is minus 1, so we are not supposed to use this formula. Why? Because when n is minus 1, your minus 1 plus 1 will be 0. So, something by 0 becomes what here? Infinity. So, when n is minus 1, what happens here? When you use this formula, x power minus 1 plus 1 by minus 1 plus 1. So, x power minus 1 plus 1 is 0 by what here? 0. So, it is anything power 0 is 1, 1 by 0, 1 by 0 is infinity. So, that is the reason it does not exist here. So, n is minus 1, you should not use this formula. Then what happens is here? X power minus 1 becomes 1 by x. X power minus 1 becomes 1 by x. So, integration of 1 by x already you have seen here. Integration of 1 by x is log x. So, integration of 1 by x is log x. So, when n is minus 1, x power minus 1 becomes 1 by x integration is log x. So, there are some small problems are there. Integration of x power 5 dx on this formula here. So, x power n is n plus 1 by n plus 1, x power 5 is what? X power 5 plus 1 by 5 plus 1. So, it is x power 6 by 6. So, n is 5, you can use this formula. So, if it is 1 by x power 5 is there, 1 by x power 5 dx. So, write down this in this form here. So, x to the power of what here? Minus 5 dx. So, use this formula n x power n plus 1 by n plus 1, x power minus 5 plus 1 by minus 5 plus 1. So, it is x power minus 4 by minus 4, right. This minus sign you can write in the numerator 1 by 4 x to the power of 4, my x power minus 4 becomes plus 4, right. So, like that here you can use this formula here. So, it is integration of root x dx is that. So, write down this root x in this form here, x to the power of 1 by 2, right. So, x to the power of n formula. So, x to the power of half plus 1 by half plus 1. So, x to the power of half plus 1, add half and 1 here, take LCM for this, right. Put 1 by 1 and take LCM 2. So, 1 plus 2, this is how much here? 3 by 2. So, half plus 1 is how much here? 3 by 2 by half plus 1 is 3 by 2. So, it becomes 3 by 2 becomes what here? 2 by 3, 2 by 3 x to the power of 3 by 2. So, using this formula we have some small examples like this. Similarly, you can have some problems like this. Integration of x cube 2x cube plus 3x plus 5x dx. So, integration of this type is there, for example. So, integration of 2x cube, integration of 3x, integration of 5 dx. So, 2 is a constant. The constant terms you can bring it outside, integration of x cube dx. The 3 is a constant, out, x dx. The 5 is constant, out, integration of dx. So, 2 x power n formula. Just now I told you x power n plus 1 by n plus 1. So, x power 3 plus 1 by 3 plus 1. So it is 3 x to the power of 1 here. X power n formula, x power 1 plus 1 by 1 plus 1. So it is 5, integration of dx is x. So it is just 2x power 4 by 4, 3x square by 2 plus 5x. How integration of dx is x, you know here. Dx is derivative of x here. The integration derivative, both are what that here, integration is antiderivative. The integration derivative cancels here, integration of dx is x. So in that way, so the formula, integration of x power n formula is used here. So there are some problems here based on substitution here. Integration of, for example, sin cube x into cos x dx is there. How do you integrate means? This is called integration by substitution here. Put sin x equal to t. The sin x derivative is what here? Cos x. So that's the reason you have to put sin x equal to t. When you put something is equal to t, differentiate and find out what that here dx here. So sin x derivative of sin x. Why should you put sin x equal to t means? The derivative of sin x is available here, cos x. That's the reason you are putting sin x equal to t. So derivative of sin x equal to derivative of t. So derivative of sin x is what? Cos x, right? And next is what that here? Dx here. So sin derivative is cos x. So again what comes here? Dx equal to what? Dt. So find out dx equal to what? Dt by cos x. So substitute here, integration of, in place of sin x you can write what here? T cube, cos x no change, dx is what here? Dt by cos x. So whenever you put anything is equal to t here, differentiate and find always what? Dx. Always find out dx. Substitution method. When you put something is equal to t, differentiate and find out here dx. You got it dx here, right? Then this value becomes what here? In place of sin x, write down t. So t cube, cos x no change, dx is what? Dt by cos x. Cos x cancel. So integration of t power n dx. Just now the first formula we used just now. Integration of x power n dx is what? X power n plus 1 by n plus 1. So using this formula, it can be written as what? T power 3 plus 1 by 3 plus 1. It is t power 4 by 4. What is t substituted here? Because the answer should be in terms of x. When the question is in terms of x, the answer also should be in terms of x. So write down substitute what is t. T is what here? Sin x. So it is sin power 4x by 4. So that's what here. So this is by integration by what that here? Substitution. Similarly, integration here, the other methods are there here. Integration by parts. What is integration by parts means here? So in differentiation like that, here two different variables are there. We use UV formula like this. Integration by parts here. So which cannot be done by integration by substitution. For example, integration of x sin x is there. So here we have put sin x equal to t and sin x derivative is cos x here. But here you can't put sin x equal to t because that sin x derivative is not available. So two different functions are there here. Such type of problems you have to do by integration by parts, right? So how do you do integration by parts means? So there is a here formula for integration by parts. Integration of u dv is equal to uv minus integration of v du. So here one function you take it as u, the other function you should take it as what here? Dv here. So which function should be taken as u means? So there is a principle here, u should be taken as inverse. If inverse is not there, go for log. If log is not there, go for algebraic. In this order you should go here, right? Inverse means sin inverse, cos inverse, tan inverse, etc. Log means log x whole square like that. Algebraic means what? X square, x cube terms here. Here no inverse term and no log term. And what is there here? Algebraic. Yes, algebraic is there here. So you should take u as what at here? X. So you should be taken in this order here. After algebraic, exponential, trigonometric is there, but we don't prefer that. Generally we took these three terms. Highlight we say here. So u is what at here? X, and dv is what at here? Sin x. So we will take u as what at here? X, and dv is what at here? Sin x. So u always should be differentiated. Why? Because you wanted here du. And dv must be integrated because you wanted here v here. So this should be differentiated and this should be integrated here, right? So in such case what comes here? D of u is equal to d of what that here? X, integration of dv, integration of what that here? Sin x. Sin x dx, of course, sin x dx here, right? Integration of dv is v, integration of sin x is minus cos x. So, you got du and what that here? You got what that here? V. So, u du v dv, substitute in this formula here. So, when you substitute in this formula, what comes here? U is what here? X, dv is what here? Sin x dx, u is what here? X, v is what here? Minus cos x minus integration of v is what here? Minus cos x, du is what here? Dx. So, u du v dv are substituted in this formula here. So, that is, if you see this formula here, in the integration x was there here, no x here, x has gone here, right. So, because of to eliminate this x here, we have used integration by parts here, right. So, it is just minus x cos x, minus into minus plus, integration of cos x. So, what is integration of cos x? Sin x. So, minus x cos x plus what here? Sin x. So, this is what integration by parts here. Similarly, integration here one more methods, so many methods are there. For example, integrations of the type 1 by x square plus 3x plus 5 is there. Algebraic terms, ax square plus bx plus c. Any integration of the form ax square plus bx plus c here. So, how do you evaluate this type of integrals? So, there are two methods here. One way of doing is what you have partial fractions. You can't do partial fractions here because you won't get factors for this. So, you make it perfect square here. When the denominator is the form of x square, x and constant term is there, or even root term is also there. So, make the denominator perfect square. How? Treat this as a square and treat this as 2ab, add b square and subtract b square here. So, when you add and subtract b square, how do you get b square means you know here. So, your a square is what your a square is x square. So, when a square is x square, a is what here? X, and 2ab is what here? 3x, 2ab is 3x. So, here 2 into a is what here? X, b is b only, is equal to 3x. So, for what sake we are doing here? So, a square is known, 2ab is known, it is not b square here. So, you have to find out b here from here, right. So, x cancels here, b is equal to 3 by 2, b square equal to what here? 9 by, squaring on both sides, 9 by 4. So, b square you got it here, a square 2ab is there, add b square and subtract b square. So, that gets you what your integration of 1 by x square plus 3x. So, a square is there, 2ab is there. Now, the b square value how much you got here? 9 by 4. Add 9 by 4, subtract 9 by 4. So, already what is there here? Plus 5 is there, right. So, integration of, so it is what form here? This is a square and this is 2ab and this is what here? B square. So, these three terms together becomes what that here? A plus b whole square. So, minus 9 by 4 plus 5. So, take LCM here, 4 5 are 20, 20 minus 9. So, 20 minus 9 is 11 by 4. So, if you want you can write down here minus 9 by 4 plus 5, put by 1 and take LCM 4. So, minus 9. So, 1 go 4 5 are 20, 20 minus 9 is 11. So, right. So, what is a here? The value of a is what here? X. The value of b, the b value got it here 3 by 2, 3 by 2 whole square, plus you also write out this also write in the form of what here? Square. How? Root 11 here, because 11 is not a perfect square. 4 is a perfect square, that you can write 2 square, but 11 is not a perfect square. If it is 9, you could have written what here? 3 square. If it is 9, you could have written 3 square, because it is not 9. So, 11 is not a perfect square, that is why you should write as here root 11 by this 4 is 2, root 11 by 2 whole square. Root 11 whole square is 11, 2 whole square is what here? 4. So, why should we write in this form here? Because of b is what here? 3 by 2. So, it is exactly in what form here? 1 by x square plus a square. So, there are some formulas in integration here, integration of 1 by x square plus a square. The related formula I am writing here, this formula, what formula is to be used, here, integration of, treat this as x and treat this as a here, integration of 1 by x square plus a square. The formula is 1 by a tan inverse x by a. So, here 1 by a means here 1 by, if you want you can write the formula as it is, 1 by a tan inverse x by a, you can write the formula, nothing wrong. What is a here? This is x and this is a here. Replace a by what? In place of a, this is a. Compare this with this here. The a is what here? Root 11 by 2. In place of a, write down root 11 by 2, tan inverse x. X is what here? Compare this with this here. So, in place of x, what is there here? X plus 3 by 2. So, x plus 3 by 2 by a. A is what here? Root 11 by 2. This implication here, this 2 goes up 2 by root 11. Here take LCM here. So, 2 by root 11 tan inverse. So, take LCM here. This is LCM is 2, 2x plus 3 by root 11 by 2. So, 2 cancels here. The answer is what here? 2 by root 11 tan inverse 2x plus 3 by what here? Root 11. So, enough. Thank you. Perfect. Yes, thank you.